Okay, so this one right here is actually pretty cool. Okay, so let's say you take applied with me right now, and you have friends that may take applied with another teacher. You cannot say if you get 80% and your friend gets 75% with different teachers, you can actually not say, oh, I did better than you. You cannot say that because it depends on the teacher, right? It could be that a 65 with me is pretty good compared to the rest of the class, and a 70 with Ms. Yosik might not be that good, right? It depends on how the teacher marks all of these things, right? The expectations, the pace, all of these things. So this solves that problem, okay? Let's say you take chemistry. A lot of you are in chemistry. You might take it with one teacher, and your friend is in a different class, different chemistry teacher, and they might rub it on you. It's like, hey, I got a higher mark than you. This is where you solve that problem. The only thing is you need to know the standard deviation for both classes, which technically your teacher should be able to provide you with. Okay, if you ask, that should be a given. So here we go. So what we do is we bring both normal distribution into a standard normal distribution. And how do we do that? We use the z-scores, right? Just imagine I'm a German professor right now. The z-scores, this scores, okay? To compare data from different sets. So here it is. I'm actually going to do this to scale. So Jay's final score in his class was 70% with a class average of 75% and a standard deviation of 5. Then there's Jasmine, right? Jasmine's final score in her class was 60% with a class average of 65 and a standard deviation of 7. So if I don't know anything else, you would think Jay did better, correct? Because Jay has 70, Jasmine has 60. Okay? So we're going to solve this conundrum. Graph a normal distribution for both classes. So let's do Jay's first. The mean for the class is 75. So we're going to put the 75 in the middle. So it's going to be somewhat tricky, folks, but you can do this. Let me just get the page numbers right here. So in the middle, somewhere in the middle, we're going to find a 75. And I think this is the middle right here. This is the 75. And then we're going to go 1, 2, 3 standard deviations to the right. And in this case, the standard deviation is 5. So that's fairly easy to do. 90, right? So 75, so forth. Then do the same thing going to the left. You subtract. 1, 2, 3, 4, 5. I tried to make the markings a little darker, but obviously it didn't work out so well. So our mean is right here. Let's go to the mean. I won't do that just yet. We'll do the same thing on the other side. Let's go to this one. So this is Jay's class, and this is Jasmine's class. And let me zoom in a little bit more. I can probably do better. So let's go to the middle. The middle is right here. And for Jasmine, the average of the class is 65 and a standard deviation of 7. So I'm actually going to count 7, folks. Okay, I'm going to count 7 marks. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then you fill this in. This would be 72. This would be 79. This would be 86. And then going left, 5 and 2, that's 7 here. So I'm actually counting 7 markings, okay, to make it to scale. So that'll be 58. 1, 2, 3, 4, 5, 6, 7. That puts me right here. That is 51. And I'm going to count 7 one more time. 1, 2, 3, 4, 5, 6, 7. So that puts me right here. I have to extend that a little bit. That puts me at 44. Can you tell which one is going to be flatter? Which one is going to be more spread out? Yeah. The 7 is more spread out, right? I had to actually lengthen that line that I've created here. This one is a little narrower because the standard deviation is smaller. So let's just make that a thing here. We're going to make this, the top of it, a little lower than the top on this side here. We're going to go to the middle and just make that point a little higher. And then you're going to go and make your curve. Okay? Page 43. Then we go to this curve and just do the same thing. Okay? We're not going to fill in percentages. We're not going to do that. For J, he is where? J is at 70%, correct? So this is J right there. J is positioned right there. Whereas Jasmine is where? Jasmine is actually right there. That's the 60 mark right there. They are both below the average, correct? Of the class. So that's something to note. Who seems to be closer to the average though? Jay or Jasmine? Oh, it's very close. I did it on purpose so that you couldn't just flat out tell. Okay? So we're gonna calculate the z-scores for each student. So we're gonna do that for Jay here. His z-score is, do you remember the formula? 70 minus 75. So the actual score minus the average divided by standard deviation. And you get a z-score of -1. So he's exactly 1 standard deviation below the mean. Jasmine, we go, her actual score is 60, right? So 60 minus, what's her average? 65, correct? Divided by a standard deviation of 7. Her z-score is -0.71. Now we're talking. Now you can compare. Who do you think did better between the two? Jasmine. Why? Closer to the average, right? Or not as far below the average as J. Okay? So did better. Not as far below the mean than J. Not as far below the mean as J is. Okay? So now Jasmine can be like, well, actually, I may have gotten a 60, but compared to the class, right, I'm actually closer to the mean. So technically that would make you in a position to say, I did better than you slightly, not by much. But so basically what we're doing is we're standardizing. We're putting both curves on a same normal distribution curve, which is called the standard normal distribution. So here it is, folks. If you have a different color, I'm just gonna, oops, one more time, talk about the standard normal distribution. It is similar to the normal distribution, but it only has z-scores. We could have stopped there because I think you got it when we did the z-scores. But one more time, I'm going to just say this is 0, 1, 2, 3, -1, -2, -3. And remember, there could be more than 3 to either side, but we usually stop there because most data is going to be within. And my right pen just fell. So try that again. So we know that J is right here. Jasmine is going to be, so 1, 2, 3, 4, that would be 0.8. 3, that would be 0.6. So Jasmine is right there. I would say this, the greater your z-score, the better you've done. Okay? So if you compare a bunch of z-scores, the one that's the highest is going to win, okay, when it comes to test scores. Since we are dealing with final scores, a greater z-score is more desirable. If you were to be a company, and I don't know why I always talk about chip bags, potato chips, you would not want your potato chip bags to be too big, right? The z-score to be too great, because that means that you're overfilling it too much. You're losing money, right? So you have to be aware of the context. Okay? But when it comes to scores, which is quite popular, that is it. Okay? So most of the time, the question will prompt you to figure out both of them, the z-scores, and then just tell me. Like, I won't normally ask it to graph like I did here. It'll basically just come down to this, and then you just have to tell me who did better. Okay, I just thought I would give you graphs so you can wrap your head around it. Okay, all right. So this is one of the miscellaneous items. Now we're gonna go jump a few pages. I'll tell you to come with me to 51. Okay, so that's another. This is going to be determine the mean and the standard deviation by hand without using the TI. Okay? So you have instances where you're not going to be given a whole lot of numbers. This is page 51. Okay, you use this. This method is used when they're given limited information about the data set. The question will often mention percentage of values located between them or the associated z-scores. Okay. If the question, for whatever reason, mentions one of these percentages, folks, you should recognize that. 68, 95, 99.7, it's no longer random. Okay? So if it says 68% of the data fall between these values, we know that it is talking about plus or minus 1 standard deviation. So if it's talking minus 1 standard deviation and plus 2 standard deviations, how many gaps are there between the values? And you just count 1, 2. There are 2 gaps between the values. If it's talking about 95% of data points lying in between the 2 values, it's plus or minus 2 standard deviations. How many gaps do you have if you go minus 2 and plus 2? How many gaps? Count. 1, 2, 3, 4. 4 bins. Okay, 4 gaps. And the last one is 99.7. That would be 6 gaps, 6 bins that we're adding. Can you just highlight that? If it doesn't mention 99.7, it will say the majority. It's the same thing. If it says the majority of data points fall between these two values, it's talking about 99.7%, which includes 6 bins, 6 gaps in between. That's going to be important for this concept that I'm about to talk about. So, here are the formulas that you need to add if this ever comes up. We can use the following formulas. I'm going to highlight them. I'm just going to find, I had it figured out here, sorry. There it is. Just box them in. And there's a caveat here. Start with this, okay? Start with this one. Because you need to know the standard deviation in order to plug it in here and figure out your mean, okay? So that's why I start with this one. What is it saying, guys? Upper value minus lower value. Listen carefully to this one. This is going to be like weight in grams, time in years, time in hours. It's going to be actual values. It's going to be test scores. What does Z up and Z low mean? Z score for the upper value, right? Because every value has its Z score. And Z low is the Z score that belongs to the lower value. So we subtract those two things. We subtract their Z scores, and then we divide. And that's how we find the standard deviation. Okay, I'm trying to explain this one to you. I made this one up, right? So full disclosure, no textbook will show you this one. And then to calculate the mean, right? This is only when I don't give you a bunch of values, right? It'll be quite obvious. X is the value considered, standard deviation, and the Z-score of the value is going to be entered here. Okay. Let's go and put this into motion here. Let's practice this. So this is the scenario where you're going to have to use that kind of reasoning, the one I just talked about there. A farmer fills bags of potatoes in order to ship them to a local market. After weighing all the bags, she finds that 95% of the bags weigh between 56.4 and 65.6 kilograms. Did anything catch your eye? This 95%, did that catch your eye? I hope so. That's very important. 95% of bags weigh between 56.4 and 65.6. Assume that the distribution of the weights is normally distributed. That's good to know. Okay, then we can apply everything we've learned. Determine the mean weight of the bags. Determine the standard deviation of the weights. Okay. So I'm gonna just preface this. Okay, preface. Can't use normal CDF. Okay. Since the mean and standard deviation are unknown. So I don't know, sometimes students try things here with those. It's like you can't. You don't know the mean nor the standard deviation. Don't even bother with it at first, right? I'll make a bullet. This is the main reason. Another reason is we don't have data points as well. So that we don't have the 50 values, the 40 values, like the values that I'm going to give you. No frequency table either. Okay. So A and B, we're going to do A and B together. It says find the mean, find the standard deviation. Start with standard deviation. Okay, we're going to find this first. So here we go. If I tell you 95%, if this is the mean here, then I'm talking 1, 2, 1, 2. Right? This is 95% of the values, it says, are comprised between these two values. And the lower one is 56.4 kilograms. So you put the 56.4 here, and you put the 65.6 here on the upper. Okay. This is the scenario I want you to think of. 2 standard deviations to either side. Okay. So standard deviation using my formula is the upper value, which is 65.6, minus the lower value, the lower weight, divided by, what's the z value of the z-score of the upper value in this case? What's the z-score for this one? 2. And this one? -2. Yeah, oops. Okay. So z up minus, what's z low? -2, right? And so when you subtract it, you get, at the top you get 9.2, and at the bottom you get 4. And so your standard deviation is 2.3 kilograms. Hold it, can that be right? Is that accurate? You can actually test it. You could go start at 56.4 and just start adding a standard deviation. Do it 4 times. And if you do so, you should get this value. Or vice versa. You start with the upper and you start subtracting standard deviations to the left. You should end up there. So if you absolutely want to make sure you got this right, that's how you do it. Okay, so standard deviation, check. Now I'm going to find the mean. And I'm going to use my formula. Okay, this is where you need to pay attention. You can pick either one of these values as your x value. If you use this as your x value, because that's what the formula calls for, you go 56.4. What's the z-score for this one? -2. Okay. Sorry, I'm looking at the wrong formula. Sorry, guys. Calm down, calm down. I got it. Standard deviation times the z-score, which is -2. And you know what? If you're careful, you can type this in exactly the way you see it on your calculator. So I'm just going to show you. 56.4 minus, use brackets, 2.3 times -2. You can't use the minus button for this -2. And the answer is 61. Could it be that you find a different way of doing this? Yes. If you find another way of doing what I'm doing, go for it. Just show me your work. Or you could also have used the 65.6 minus the standard deviation, still 2.3, and the z-score there is 2. So you go 65.6 minus 2.3 times 2, and that's still 61. So if you, whichever value you use, stick to that z-score that belongs to it, right? And I'm just going to highlight a few things here. The 2.3 that I found, that's what I need in this formula, right? So basically, once I determine that, I use it to figure out my mean. So now you have your mean and your standard deviation. C, I'm doing this to review for the quiz as well. C, what percentage of bags weigh less than 57 kilograms or more than 65 kilograms? how would you do this one? There's two normal CDFs or one normal CDF, whichever one you would like to do. Yes, so 57 would be somewhere in here. This is 57. And 65 would be somewhere on the upper end here, 65. So they want this, more than this or less than 57. This is what we want. So I'm just going to say 1 minus normal CDF, and I'm going to figure out 57 to 65, and my standard deviation and mean I know is 61, 2.3. So it's 1 minus, I don't have that on my, let's call normal CDF, 57, 65, 61, 2.3. So that's 0.9179 and something. So I'm going to go 1 minus, you can't see that on the screen, right? 1 minus that, which is 0.0820 something, and multiply that by 100. That's 8.20% of bags are fitting this criteria, both tails. I'm just going to make sure that the 0.9179 is this chunk right here. I subtracted from 1, and so to me that's easier than doing 2 normal CDFs, to be honest, and then adding that up. So regardless of how you do it, you should get it. The farmer would like to remove these bags, right? If 785, so this is D, if 785 bags were produced and this many are removed, all you would do is you would use that and multiply it by 785. So 64.38, which is approximately 64 or 65 bags are going to be removed. E. And then I'll lead you to it. If you can read it, right? What weight would result in 55% of the bags weighing less than it? What function are you using in that case? Inverse norm. All right. So I don't know. I like to do a quick curve like this. What weight would result in 55% of the bags weighing less than it? In my opinion, if you read this carefully, your line that cuts this curve is somewhere up, because that weight will have 55% of bags weighing less than it. You have to find where it is on this curve, and you do that. So inverse norm. Is this already to the left? Yes, so they already gave the percentage to the left, so 61, 2.3. Sorry, I'm blocking, I know. I'm just going to quickly enter this. So once you have your mean and standard deviation, it goes back to kilograms. So 61.29 kilograms will result in this, where 55% of bags weigh less than it. Just slightly over the average, right? The average is 61. So it makes sense that it's 55% because you're slightly over the average. Okay. If you want to practice this stuff, if you're like, 53 to 54, page 53 to 54 will have that. So I'll post that. Will there be tons of these questions? No, there will be just one like this. So you just have to be comfortable with that. Everything else is the same as before. Okay, so if you go through, let me just stop this here.